Now the next measure of central tendency identified in the branch of statistics is mode. Mean, mode and median. So let's start with mode. Mean is the average of the data, and then let's see what is the basic definition of the second measure of central tendency, which is mode. So definition of mode. The data which occurs most number of times is called the mode. So in this case, we call the mode as the data which, or the observation here, the more specific word is the observation which occurs most number of times or most frequently. To start with an example problem, let's understand mode in a more better fashion. If suppose I have a cricket match as a real life example connected with the mode, let's see how mode is understood through a cricket match. A bowler takes the following wickets, the following number of wickets in 10 matches. That is, I have 2, 6, 4, 5, 0, 2, 1, 3, 2, 3. Now in this case, it is clearly given that the bowler takes, in the first match he takes 2 wickets, in the second match he takes 6 wickets, in the third match 4 wickets, in the fifth match he doesn't take any wickets, not a good performance here, and then finally in the 10th match he takes 3 wickets. Now I want to understand this problem through the mode, the basic mathematical or the statistical measure of central tendency called the mode. So let's see how we understand this problem through the mode. Now as we see the definition, it clearly says that mode is the observation which occurs most number of times. Therefore, let's follow through the definition and identify the value of the given scores or the given wickets of each of the matches. So as I see here, clearly I have the data here which I'm going to write in order. The first thing which is very important out here is arranging the mode in a definitive order, whether increasing or decreasing or ascending or descending order. So in this case, I arrange the data in two, 3, I have 3s, 2 3s, 1 4 and 1 5 and 1 6 finally. So all the 10 matches, all the wickets are taken in different order. Now we identify that performance which has most number of wickets taken. So as I clearly see that 2 is repeating more number of times, therefore here we identify by the definition of the observation which is most number of times as mode, we identify that the mode is 2 strictly by this definition. When the mode is 2, what does this mean in real life is the biggest question out here in case of mode. What do I mean by these values which lead to 2? What do you mean by understanding that mode is 2? That is, when I take the match or the real life situation of a bowler taking the following wickets in 10 matches, mode equal to 2 implies the bowler takes 2 wickets for most number of times, in the 10 matches is how we understand through the mode. It's very important to understand mode in real life because the value of the mode will make us predict on the most number of times that the player, or the bowler in this case, takes 2 wickets in 10 matches. So his performance mostly has been taking 2 wickets in each of the cricket match which has been played by the bowler. This is how we understand mode connected with real life situation. So let's see how we can calculate the mode for the group data, that is the data which is grouped into different class intervals. Now let's take the same problem as we have discussed in the previous session, where I have taken the class interval of all the marks as obtained by the students in the class for the subject of mathematics, the maximum marks being 100. So here I have the class interval with the class length of each class interval being 15 and frequency of each of the class as given in the second column. Now, to find the mode for such group data, we have a specific and an exclusive formula which we calculate using the mode which is given by the formula L plus F1 minus F0 by 2 times of F1 minus F0 minus F2 times of H is the formula which I exclusively use in finding the mode for the group data. So let's see what each of L, H, F1, F0 and F2 stand in their respective definitions. To start with L, L is called the lower limit of the model class. So L is called the lower limit of the model class, and of course H is called the class size, or the size of the class interval, which is 15 of course here, as taken even in the previous problems. Now F1 is the frequency of model class. So frequency of model class is denoted by F1, and F0 is frequency of preceding class. So preceding class in the sense the class which is above the model class, that frequency is considered as F0, and F2 is the frequency of succeeding model class. Succeeding class, that is the class which is below the model class, is the frequency of that class which is below the model class is F2. So let's see how we can calculate each of LH, F0, F1 and F2 for this group data as an example problem. Now coming to this, let's see how we can find the mode of this group data using this formula. As I find here, now the model class is the class which has the highest frequency. For a group data, because the frequency is highest here, this class is called the model class. Generally, the model class is identified with its highest value of the frequency, and that class stands for the model class. So in this case, my L is lower limit of the model class. Therefore, as I see here, my model class being 40 to 45, this is the lower limit 40, and 55 is the upper limit. So L is what I require. Therefore, in this problem, my L is 40, the lower limit of the model class. Similarly, my H is the class size, which I can clearly see is 15. The length of the class, or the class interval, is 15, so my H is 15. My F1 is frequency of model class. As I see that the model class is clearly in the third row, therefore this is the frequency of the model class. Therefore, my F1 is 7. Similarly, my F0 is the frequency of preceding class. Therefore, this being the model class, my preceding class frequency is 3 and my succeeding class frequency is 6. Therefore, this stands for F0 and F2 for 6. Therefore, my F0 is 3 and my F2 is 6, is how we extract using the basic definitions in the formula. So substituting each of these in the formula, therefore my mode, which is L plus F1 minus F0 by 2F1 minus F0 minus F2 times H, I substitute each of L, which stands for 40, plus F1, which is 7, minus F0, which is 3, by 2 times of F1, which is 2 times of 7, minus F0, which is 3, minus F2, which is 6 times of 15, because times of H is times 15. Therefore, when I simplify this, I get this to be 40 plus 7 minus 3, which is 4, and 14 minus 9 is 5 times 15, 5 ones, 5 threes. So this is 40 plus 2L, which is 52. Therefore, mode of the given class interval table or the group data is 52. So we identify the mode of the class to be 52 is how we identify. Now let's see how we can compare mean and mode. As we have discussed about mean and the mode for the group data, let's recall the previous example problem and see how the comparison is done between mean and mode for better understanding of the topic connected with real life. So as taken with from previous example, I got my mean is 62 and my mode, which I obtained as 52. So with these values, I would like to compare, because the previous problem was referring to the marks as obtained in the subject of mathematics by the students in the class. Therefore, this value gives me that mean equal to 62 means on average each student got 62 marks out of 100 in mathematics is what I understand with mean equal to 62. It means on average each student got 62 marks out of 100 in maths. Similarly, mode equal to this 52 implies it means most number of students got 52 marks in the whole class, of course, out of 100 is how I understand the mode and mean compared connected to real life. So when I come to mode, it means the most number of students who got 52 marks. This is on average each student got 62 marks. So mean refers to the average and mode refers to the most number of times or most occurring part. Therefore, each of the definition of mean and mode have their own respective understandings as seen through this example. Mean is average of each student and mode is most number of students getting that particular marks. Here mode is 52 and mean is 62 is how I understand the difference between mean and mode. Next, the third measure of central tendency is median. Mean, mode and median. So what is median? One of the measure of central tendency which I have identified here is median. So what is a median? So median is generally referred as the middlemost value. So when I basically understand median, I understand this as middlemost value of the data or of the observation is called the median. Of course, the rule here is that we take the data or observation is arranged in order. Generally, we arrange in order. Either it can be ascending or descending order. The first and foremost rule of identifying the median is initially the data being arranged in ascending or descending order. Then the middlemost value of the data is nothing but median. For example, I take 5, 4, 3, 6, 1, 2, 9. So I try to arrange this in order so that this on order gives 1, 2, 3, 4, 5, 6, and 9. Now, as I see the middlemost value, I get it by cancelling this with this, this with this, this with this, and this is the middlemost value. Therefore, this middlemost value is called median. Therefore, in this case, the middlemost value being 4, here median is identified to be 4, is how we understand median connected with the data, the middlemost value. Now, interestingly, here I identify that if I have two values which come as the middle value, say for example, the number of observations here is 7, but if I have 8, that is if n is even, if the number of data is 8, I have two values which are the middle values. The question out here comes, which value is considered to be the median? If you have two numbers in the middle, how do we calculate the median is the biggest question if n is even. So therefore, let's see two different cases where n is even and n is odd. This example where n is odd, n is the number of observations, therefore 1, 2, 3, 4, 5, 6, 7. So n is odd, therefore I got median as 4. So let's come with two different special cases, n even and n odd. So let's take the even and odd cases. To start with, let n be the number of observations of the data. Now, if n is the number of observations of the data, then if my case 1 is n is even implies n is odd implies then n plus 1 by 2 is 1 by 2th observation is referred as the median, is the median. So therefore, for n being odd, n plus 1 by 2 is referred as the median. That is, the observation n plus 1 over 2 gives me the median. Similarly, if I take n is even, then I have n by 2 plus 1. Now, in case 2, if n is even, you have two observations whose average is considered as the median. That implies average of n by 2 plus 1th and n by 2th observations is referred as the median. So here, the median is the average of this and this. If n is odd, the middle term, that is n plus 1 by 2th observation, is the median. So therefore, we should need to be proper care is taken when n is even. We get two values whose average is considered to be the median. The two special cases, n even and n odd. Now let's see how we can calculate the median for group data. But before we understand calculating of median through the group data, we need to understand the basic fundamental of the cumulative frequency derived from the general frequency. As I have here the marks obtained, which is the class interval for the group data, and the number of students, which is the frequency, let's see how we can find the cumulative frequency. Now, as I come to frequency, cumulative frequency can be derived strictly from this by using the two different types. One is the less than and the greater than. So when I take the marks, say in the situation where I say the number of students who got marks less than 10, or I say the students who got marks which are less than 10, and this is the class where the students got marks less than 20, that is, even the 0 to 10 is included in this, is how we differentiate between the frequency and the cumulative frequency which you are going to derive here. Now, frequency 3 clearly indicates that there are 3 students who got the marks between 10 and 20, but less than 20 indicates that there are 5 plus 3, totally 8 students who got marks less than 20, is how I differentiate between the frequency and cumulative frequency. Frequency restricts only to that row. Cumulative frequency takes into account even the previous rows. However, the number of rows exists above it. Therefore, if I take all the marks less than 30 and then here less than 40 and less than 50 and less than 60 for a test where the test is given for totally 60 marks, this is how I take the less than type. So let's see how the less than cumulative frequency is calculated from the given data of marks which are taken into account. So less than cumulative frequency we get by taking the marks obtained which are less than 10. I have the frequency is clearly 5. But if I want to know the marks obtained which are less than 20, I have 10 to 20 and 0 to 10 which are given by 5 and 3. Therefore, 5 plus 3 is what I get as the cumulative frequency for the marks which are less than 20. Now for the marks which are less than 30, I have the marks from 0 to 10, 10 to 20 and 20 to 30. Therefore, I add each of them. So it's a stepwise adding where I get 8 plus 4 which gives me 12. In turn, 12 plus 3 gives me 15 is how I identify the sequence or the pattern. Similarly, 15 plus 3 is 18 and 18 plus 4 is 22 is what I get the less than cumulative frequency denoted by cumulative frequency of less than type, which we have here, less than cumulative frequency. So this is how I obtain the cumulative frequency less than type in case of the marks which I want to find which are less than 10, less than 20, less than 30 and say etc. till less than 60. Similarly, if I wanted to calculate the more than cumulative frequency or the greater than cumulative frequency, then here I take the marks which are greater than 10, greater than 20 or 30 etc. So the less than changes to greater than. So let's see how the greater than cumulative frequency is calculated for the same example problem connected as seen with less than cumulative frequency. To be continued with greater than cumulative frequency. So let's see how the greater than cumulative frequency is calculated. To start with, let's take the marks which the student has obtained are greater than or equal to 0. To start from bottom, I want to know the number of students who got the marks greater than or equal to 50. Clearly, the maximum marks is 60. So there are 4 students who come in this range. So for greater than cumulative frequency, similarly when I say the number of marks which the students got greater than or equal to 40 would include this and this, because 40 to 50 and 50 to 60 are the marks greater than or equal to 50. So this range comes here where this is 3 plus 4. Therefore, there are 7 students who got the marks which are greater than or equal to 40. Therefore, in case of this, I identify the pattern from bottom to the top. 4, 4 plus 3, 4 plus 3 plus 3, 4 plus 3 plus 3 plus 4, etc. is the pattern which is identified. Therefore, in order to find the greater than case, my greater than cumulative frequency is obtained by proceeding from bottom to the top, where in less than cumulative frequency I proceed from top to bottom. In this situation, I take 4 and then I get 4 plus 3 which is 7, then 7 plus 3 which is 10, and 10 plus 4 which is 14, and 14 plus 3 which is 17, and 17 plus 5 which is 22 is what I get as the greater than cumulative frequency. So therefore, less than or greater than cumulative frequencies are proceeded in the respective manner, where less than cumulative frequency we add from top to bottom of the frequency, and greater than cumulative frequency we add from bottom to top in stepwise process where I get this. So let's see how a problem can be calculated, where median can be calculated for the group data using the cumulative frequency, greater than or less than cumulative frequency. Using that, we find median. So let's see how we can calculate median for this group data using the cumulative frequency as discussed in the previous session. So with this example problem, I calculate median for this group data. So initially, let me calculate the cumulative frequency denoted by CF. Is denoted by CF, and we are going to find this using the cumulative frequency. So to go with initial step, my initial value is 5, then 5 plus 3 is 8, 8 plus 4 is 12, 12 plus 3 is 15, 15 plus 3 is 18, 18 plus 4 is 22. So this is how I find the cumulative frequency CF. So once I find the cumulative frequency, the formula for median for a group data is given by median equals L plus n by 2 This is the formula for the median. L plus n by 2 minus CF by F into H, where each of L is the lower limit of median class and n is the number of observations, where in this case for group data n is sigma fi, that is sum of all the frequencies, and my cumulative frequency is the cumulative frequency of the preceding class, that is the class before the median class. The cumulative frequency of the value which is above the median class of the preceding class is what we get, and F is frequency of the median class And next, finally, H is class size. As we know, it is the length of the class interval. So the formula median given by L plus n by 2 minus CF by F into H, where L is lower limit of the median class and n is number of observations, which is given by the formula sigma fi, and CF is cumulative frequency of the preceding class, that is the class above the median class, and F is frequency of that median class, and then H is class size. So let's use this formula in substituting each of the contents as derived from this table. So to start with, clearly I identify initially with the median class. How do we identify the median class is the biggest question out here. So let's see how the median class is identified. So first we consider n by 2, which is n, as I see here, is totally sigma fi. N is sigma fi, which is 4 plus 3 plus gives me 22. So my n is 22, which is sigma fi. So n by 2 is 22 by 2, which is